Okay. Can everyone see the screen? Sadia, can you just let me know in the chat? Can you see the screen and hear me? Sadia? Okay, this is my first time going live. And we're actually going to be going through a predicted paper. So we are going to be going through a predicted paper for GCSE Physics for the AQA spec. This is a 1 hour 45-minute paper, so it's quite long, but I'm going to go through it quite fast because I know your exams are tomorrow. Okay, so firstly, let's go through question 1. So it says, which of the following particles carry a positive charge? Okay, so for this one, we know straight away that it's going to be a proton. Yeah, so protons carry a positive charge. Neutrons are neutral, so they don't have any charge, and electrons, they have a negative charge. Okay, question 1.2, what's the approximate frequency of UK mains electricity? Okay, so again, we know that the frequency is 50 hertz and the voltage of UK mains electricity is 230 volts. Okay, so that's a mark, that's a mark. Let me just get my pen for my graphics pad. I'm not actually too sure where it's gone. Okay, the third type, it says which type of energy is transferred when an object falls from a height. Okay, so when an object falls from a height, which type of energy is transferred? Okay, so here we don't actually have, it should say gravitational potential, but yeah, it starts from gravitational potential and then it converts into kinetic. So this is a bit of a badly worded question, but it does convert into kinetic. Now the next question, it says a weightlifter lifts a 50 kilogram mass 2 meters above the ground. What is the gravitational potential energy here? So it's mass times gravity times height. And so your answer is just 50 times 2 times 9.8. So it's going to be 980 joules. Okay, so that is your 1.4. So next question, if the weightlifter takes 5 seconds to lift the weight, what's the power output? Okay, so if he takes 5 seconds to lift, we know power is energy times time. Yeah, so we would just do 980 times by 5. Sorry, energy divided by time. So 980 divided by 5. So let's check what that is. 196. And the units for power are watts. So give yourself 2 marks if you got that. Okay, it says next, what happens to electron? So if a plastic rod is rubbed with a cloth, what happens to the electrons in this process? So again, I would try and have a go at these questions. So what happens to the electrons in this process? And whilst you're doing that, I'm just going to quickly try and find where my pen has actually gone. Okay, so I've got my pen now, so hopefully it's just going to be a lot easier to write on the screen. So a plastic rod is rubbed with a cloth and it becomes negatively charged. What happens to the electrons in this process? Okay. So remember what rubbing materials together do. So rubbing materials together cause the electrons to be transferred. Okay. And then electrons are transferred from one object to the other, which leaves one object positively charged and the other negatively charged. Okay. So you'd get a mark for stating that the electrons are transferred from one object to another. Yeah, so one object to another. And secondly, the rod gains electrons and becomes negatively charged. Okay, so the rod gains electrons and becomes negatively charged. Okay, next it's asking what would happen if this rod were brought near a neutral piece of paper. Okay, so what would happen if the rod was brought close to a neutral piece of paper? So it would become positively charged if it came close to like a neutral piece of paper, because a charged object that you bring near to a neutral object causes the opposite charge to come onto it. Okay, so a positive charge on the rod produces a positively charged positive charge on the surface of the paper, and then the paper is attracted to the negatively charged rod. Okay, so the paper's attracted to the negatively charged rod. So that's for 2 marks. Again, this is more on static electricity, which means that it's actually very likely for a static electricity topic to come in the paper tomorrow. So it says a balloon's rubbed against a jumper and becomes negatively charged. So if any of this doesn't make sense, please review static electricity. So a balloon's rubbed against a jumper and becomes negatively charged. What happens to the electrons? Okay, so think about what happens to the electrons during friction. So when 2 objects are rubbed, one gains electrons and the other one loses electrons. Okay? So literally we're going to be saying that in the answer. Okay? Because it's asking us what happens to the electrons in the process. So we would say electrons are transferred from the jumper to the balloon. Okay? And this makes the balloon negatively charged. So this makes the balloon negatively charged. Okay? That is what you would say for this particular question. So if the balloon's brought near a neutral wall, what happens? So again, another thing on static electricity. Here, think about what happens. So the electrons would be repelled by the negatively charged balloon. Okay, so the electrons will be repelled. Okay, and next, what for the second mark, think about what the charge on the wall would be. So the wall would be left with a positive charge. The wall will be left with a positive charge. So this is all on static electricity, and it's very likely to come up. So if you don't get it, I think you still have time to watch a video on it or to go through it in a bit of detail. That would be a really good shout. Okay, a few easier questions now. So it says a motor lifts a 15 kg object vertically in 3 meters and 10 seconds. So calculate the work done. Okay, here we know that the gravitational field strength is 9.8. So firstly, we would use F equals mg to work out the force. And then we know that work done is force times distance. So two formulas are being used here. First, you need force, so you need to do F equals mg. And secondly, you need to work out the work done, which is the force times the distance. So 15 times 9.8, which is 147. And then 147 times by 3. That's 441 joules. Okay, that's for part A. And then it says a 15 kg object vertically, a motor lifts a 15 kg object vertically 3 meters in 10 seconds. So here we know that power. Wait, what are we trying to? So we know we got the work done as 441, and we would divide that by 10 seconds because that would help us to get the power. And then the power is the rate of work done. So we would divide the work done by the time taken in this question. So it's just going to be 44.1. And the units are really important as well. So that would be 44.1 watts. Okay, 3.2. So a 15 kg object is lifted 5 meters vertically. What's the gravitational potential energy gained? Okay, so again, you're very likely to get a lot of GPE type questions in tomorrow's exam. So mass times gravity times a height. Okay, so just put that into your calculator. 50 times 9.81 times 5. And that is 2,452.5 joules. That's the gravitational potential energy. If an object is dropped, what happens to its gravitational potential energy? Okay, so this again really likes to come up. The gravitational potential energy for a falling object would be converted into kinetic energy. And it would basically decrease, because this is just one mark. It would decrease and then it would turn into kinetic energy. So you could just get a mark for saying it would decrease. What happens to the kinetic and potential energy just before of an object, just before it hits the ground? So if the gravitational potential energy decreases, kinetic energy increases, and just before hitting the ground, all of the gravitational potential energy is going to be converted into kinetic energy. So here, what happens to kinetic energy? Well, kinetic increases and gravitational potential energy decreases close to when it hits the ground. Okay, got some nice electricity questions now. A lot of students struggle on these, so pay really, really close attention. So it says a student sets up a simple circuit with a 12-volt battery and a resistor of 4 ohms. Calculate the current. So we know V equals IR, and we know I is V over R. So it's just 12 over 4, which is 3, and the unit is amps, which you could just write as A. Okay, the next part, it says that the student adds another 4 ohm resistor in series. So what's the total resistance? In series, we just add each individual resistance. Okay, so in series, we would just do 4 ohms and then add another 4 ohms. So it would just be 8 ohms. Calculate the new current. Well, the new resistance is 8 ohms. So it's just going to be 12 divided by 8 now, which is 1.5 amps. So give yourself the mark if you got that. Okay, again, this comes up and loves to come up. So in the UK wires, we have live, neutral, earth wires in the 3-core cable, which is used in the UK in a UK plug. Describe the function of each of these. Okay, so what does a live wire do? So a live wire, it's the brown wire. It carries current to the appliance at 230 volts. What's the neutral wire? The neutral wire, it's the blue one, and it carries current away and completes the circuit. But you just get the mark for saying completes the circuit. And lastly, the earth wire, which is the one that's green or yellow. The earth wire, it's the safety wire, and it prevents electric shocks. So that's 3 marks, and you should get them. Safety wire that prevents electric shocks. Sorry for my writing. It's very messy, but I'm writing with a graphics pad, so that's why. Okay, it says a fuse is placed in a live wire of a circuit. Explain why it's necessary. Okay, so the purpose of a fuse is it basically disconnects the appliance when if there's any fault. Okay, So the fuse would, in this case, it would melt or break the circuit or blow up if the current goes above a certain safety level, which is on each fuse. So it says, why is it necessary to place a fuse? Well, in the event of a fault in the circuit, a fuse disconnects the appliance from the circuit, the main circuit, and also it melts or blows / breaks the circuit. Okay. If the current goes above a safety level, goes above a safety level. Okay. Next, it says a kettle has a power 2.2 kilowatts is used for 5 minutes. What's the energy transferred in kilowatt hours? So here we would convert time into hours first. So 5 divided. So 5 minutes into hours. So 5 divided by 60, and that gives 0.08. And then you would just do 2.2 times 0.08 because you want it in kilowatt hours, which is 0.176 kilowatt hours. Okay, so we know that for the formula for specific heat capacities, E equals mc delta T. This particular question, though, you have to rearrange. So you have to find C. So you have to do E, which is 8,000 joules, over m delta T, or delta theta. So it'd be 8,000 over 1 kg times 100 minus 20, because you want delta theta. That means the change in it. So that is just 100 joules per kilogram degree Celsius. Okay. A block is left to cool in the open air. Describe the main method of heat transfer in this situation. Remember, this is convection. So you need to know conduction, and you need to know in which case each of them. So it's convection, and heat rises, and the cooler air would come to replace. So heat rises away from the block, and cooler air replaces it. Okay, awesome. Next question. Describe explain how thermal energy explain how thermal energy is transferred through a metal rod by conduction. So conduction is where particles, these are key words for conduction and convection. So this is conduction now. Particles gain energy and vibrate more towards the heated end. Okay? And then energy is passed between the collisions. So energy is passed between collisions. So 2 marks, give yourself 2 marks if you got that. And remember these key words. So conduction, particles gain energy, they vibrate, energies pass between the collisions. Okay, next question. A student heats one end of a metal rod. The other end of the rod becomes warm after 3 minutes. How could the student reduce the time taken for the other end to become warm? So you could first of all increase the temperature difference. Okay, so you could increase the temperature difference between the two ends. Or you could use a material that has better conductivity with better conductivity. Okay, so those two are for 2 marks. Okay, next it says a bungee jumper with a mass of 70 kg jumps from a bridge at maximum stretch. The bungee cord has a constant force of 400 Newton meters and the cord stretches 25 meters. So what's the elastic potential energy? Well, we know the formula is half kx squared. Force constant is that, so a half times 400, and the extension is, so a half times 400 times 25 squared. What's that? So half times 400 times 25 squared, that is 125,000 joules. Explain why the jumper does not return to the original height after bouncing. Because of the energy loss and due to the air resistance as well. And the cause of not returning to the original height. Okay, you also need to be able to define thinking distance and braking distance. Okay, so you need to understand them really well. Thinking distance is the distance that a car travels between spotting the hazard and touching the brakes. So when you spot and then touch the brakes. I'm not going to write the whole thing. And then the braking distance is when you put your feet on the brakes and then the car stops. Okay, because we are a bit short of time, I'm not going to write down all the answers anymore. But we're still going to go through them. Okay. 2 factors that could increase the stopping distance. So stopping distance can be increased by the road conditions. So whether it's icy, rainy, that could increase the stopping distance. Your car could crash into the next car. And also the speed. So the faster you're driving, the longer your stopping distance. Okay, next, if the car's deceleration is 6 meters per second squared, what's the time taken to stop? Well, we know that time is equal to the change in velocity over, here we have the deceleration. So the change in velocity over sorry, the time is the final velocity take with your initial, and then you can divide it by the acceleration. Were we given the velocity? Yeah, 30. So here it would just be 30 over 6. So that would be 5 seconds. Explain why wearing a seatbelt reduces the risk of a collision. This increases the time over which it reduces the force on the passenger. So reduces the time which the car comes to a stop. And also this reduces the force. This reduces the force as well. Okay, so this is one that a lot of people struggle on radioactivity. So it says a radioactive substance has a half-life of 8 hours. Okay, if the initial activity is 600, what's the activity after 24 hours? So how many half-lives have passed in 24 hours if each one is 8? Well, 8 times 3 is 24. So 3 half-lives have passed in that time. Okay? And we know that each half-life reduces the activity by a half. Okay? So the activity initially is 600. And then we want to, it's reduced by half 3 times. Okay? So it's reduced by half 3 times. So you halve it, then you halve it again, then you halve it again. So 600 times basically a half to the power of 3, which is 75 becquerels. Okay? 7.2, one risk of working with radioactive materials and a safety precaution. Well, radioactive materials cause damage to living cells, and you can wear protective clothing to help you to basically get over this. So ionizing radiation can kill cells, and this can potentially lead to like cancer and things, and so you have to maintain distance or use lead shielding. Describe the difference between nuclear fission and fusion. So fission is where a large nucleus breaks down into smaller nuclei. Okay. And fusion is where smaller nuclei join to make a large nucleus. So fusion is where smaller nuclei combine or fuse together, join to form larger. So if this comes up, guys, please do get it. Definitions are some of the easiest marks that you can get. Okay, so please get the definitions, because you just have to learn them. And then the calculations, most of them in the foundation paper aren't going to be too difficult either. So it's a good idea to try them. It's really, it's like really important to try and get all the ones for this. Just plugged my laptop in. Okay, next. In a nuclear reactor, uranium-235 undergoes fission. If 2 neutrons are released in each fission event and cause further fission reactions, explain what's meant by a chain reaction. Okay, guys, a chain reaction is when each fission event releases neutrons and they cause even more fission events. Okay? For 2 marks, it's a self-sustaining process. So it keeps occurring on its own as well. So each neutrons are released in each reaction. That further fission reactions to take place. Okay. One advantage and one disadvantage of using nuclear power to generate electricity compared to burning fossil fuels. So remember, guys, nuclear power doesn't emit carbon dioxide. It has very low, it doesn't really emit pollution. But, and also a good thing about it is that it produces a lot of energy. But a bad thing about nuclear power is that it produces a lot of hazardous radioactive material or radioactive waste as well. So advantage, a lot of power, not much carbon dioxide, which is great, but radioactive waste is very dangerous. Okay, it says the UK government aims to increase the use of renewable energy. Guys, I want everyone to get this question in the exam because it isn't a difficult one. Okay, so you need to name 2 renewable energy resources. So you could talk about wind, you can talk about hydroelectric power, geothermal, any of that. Remember, solar panels convert sunlight into electricity. Wind power, that's when the wind turns a turbine, which runs a generator, which turns into electricity. Hydroelectric power is when you have something up in a dam, and then the moving water that comes down through an inlet would turn a turbine and run a generator. Okay, so I think some of the easiest ones to choose here might be like wind power, perhaps solar power. So advantages and disadvantages, include them as well. And when you're explaining for each of them, it's usually the fact that you start, so like with wind, for example, you would say the wind turns a turbine, and then the kinetic energy turns or runs a generator, which converts into electrical energy or electricity using the generator. So make sure you say turbine, make sure you say generator. These are like key words. Advantages and disadvantages of solar and wind. Again, this is very straightforward. Remember that solar power, an advantage is that it works amazing in remote and hot areas, works really well. And also there's no greenhouse gases, it's renewable as well. But disadvantage of solar is that solar, it relies on the sun. So it's dependent on the sun. If it's sunny one day, you'll get a lot of energy. If it's not, you won't. Okay. And same kind of thing for wind as well. So wind is renewable. It doesn't produce greenhouse gases. However, wind power is incredibly noisy in areas. It can look ugly as well. And it's very much dependent on wind that day. So it doesn't work all the time. Okay, how long have we got? Okay, I don't think we've got too long. So it says next, a house uses 300 watt heater for 6 hours every day, it's 75% efficient. What's the total energy output in one day? So you know that how, first of all, power, time, and energy relate to each other. Yeah. So power is energy over time. So here we would do 300, but not times 6, because time is always in seconds. So convert into seconds first. That would get you the energy, and then you can use the efficiency formula. Okay, so that's 6,480,000 joules. And then, efficiency is like the useful over total. Okay, so what's the useful? It's 75% efficient, so we could just do 75 times the total. Sorry, the useful. Yeah. So 0.75 times 6,480,000 joules. That's 4,860,000 joules. That's 3 marks. That's quite a hard question, actually. But just remember the formulas and note them down so you can get the method marks. Useful over total times 100 is equal to efficiency. Okay. And then to calculate the wasted energy, we would do this, take away this. Okay. The top one, take away the second one. So 6,480,000, take away 4,860,000. So it's 1,620,000 joules. 3 marks, you just take them away. That's the wasted energy. Okay. Next question. A diver experiences water pressure of 200 kilopascals at a certain depth. Calculate the force exerted on 2 meters squared surface at this depth. Okay. This is, again, not too difficult. Think about pressure, force, and area. Think about the formula for it. So force is equal to pressure times area. So here we're just doing 200, but that's kilopascals. So don't forget to times by 1,000 times 2. Okay, so that is 200,000. 200,000. Explain why the pressure increases with depth. So pressure increases with depth because the deeper you go, the greater the weight above you. Okay, the deeper you go, the greater the weight above you, and this creates a larger force on an area at greater depths. Okay. So you'd get a mark for recognizing that pressure increases with depth due to the weight above water. And secondly, that the increased force on the area leads to a higher pressure. Just want to see. Okay, we're just pretty much done. Last two questions. We won't do this one because you would just need to plot it on the graph. You are likely to get a graph plot or something like that. So just make sure you know how to do that. Then once you've plotted it, you do the whole relationship, but we won't do that. Okay, last question then. So it says a student wraps different materials around a container of hot water to investigate their insulating properties. The table shows the temperature drop over 10 minutes. So which material is the best insulator? Okay, so you had a question on convection, a question on conduction, and here's insulator. So for the best insulator, try and find the material that has the smallest temperature drop. So, because the best insulator is the one that stops heat loss. Okay, so use the data, look at which one has the smallest temperature drop. So here it's bubble wrap, and then you could just say bubble wrap because it's got the smallest temperature drop, so it retains most of the heat. And then one way to improve the accuracy of the experiment, you could use a digital thermometer for more precise measurement. And digital thermometers have smaller, you can read them more accurately as well. So a student investigates the surface area of the container, how the surface area of the container affects the rate of heat loss from hot water. They use containers of the same material and a volume, but with different surface areas. So why should the student control the starting temperature of the water? Okay, explain why the student should control the starting temperature. So here again, you need to understand conduction, convection, radiation. So this would just ensure that heat loss is going to be measured due to the fact that the surface area of the container, the starting temperature, it should be the same as the starting temperature for each of the trials. And then secondly, predict how the surface area will affect the rate of heat loss. So if you increase the surface area, that will increase the rate of heat loss because there's more surface from which heat can escape from. And lastly, one improvement the student could make to the accuracy of the experiment. Well, so you could say multiple things for this. One thing you could say is use a digital thermometer again. And how would this affect it? Is it would reduce the human error. Okay, so digital thermometer always improves accuracy of experiments. All right, so we are going to stop there. Check your work if you've already tried it, and see if you can go over some things that you struggled on. So what I would say is, I know it is quite late, but I would still try and choose 2 to 3 topics that you think you still need a tiny bit more work, and maybe just do some passive revision, like watch a video on it. So static electricity is a really good one that you can watch a video on. Again, another good one to do is conduction, convection, radiation. That's really good to do as well. And I will be doing the same thing for paper 2 as well. So you guys have the paper in the description, download it, go through it, break it down. These are some of the things that can really come up. Make sure you know all the stuff about, geothermal and hydroelectric and all of the renewable energy resources and non-renewable, and how they actually can give us electricity as well, because that's likely to come up. But yeah, go through the paper, target the regions that you think were quite hard. I think personally this stuff can be quite difficult, so if you need to watch a video, Free Science Lessons has great videos, but I'm sure you guys know more than me for what's available out there. Radioactive substance, a good one to go through. Make sure you know all your definitions. Make sure you know what thinking distance is, what breaking distance is. Okay, just push and try and do your absolute best, and go into the exam feeling confident. If you don't get a question, star it and come back to it, and make sure you use your keywords. Okay, keywords always come into keywords are always really, really important. So like keywords for convection is like heat rises away, cooler air replaces it, conduction, particles gain energy, vibrate, and then that energy is passed between the collisions. Make sure you use that. Make sure you know live wire, neutral wire, earth wire. That's very, very important. And the rest calculations, if you note down all of the formulas you're using, you can gain marks, even if you lose marks on the final question. Make sure you know static electricity. This can be a difficult one, but if you need to go over it, do that and then write keywords that you're going to use in a static electricity question. And yeah, all right, we'll stop there then. I'll do the same for paper 2, and then we're just going to end it there. All right.